right, y'all. Properties of exponents. We're going to use them to simplify expressions and find some values. All right, so let's go. I'm going to first talk through these three properties, and then we'll do these three examples. So, first property, product of powers. You don't have to know this name, you just have to know how to use it, okay? So A is a real number, M and N are integers, which means they are whole numbers that are either positive or negative. So like -1, 0, 1, 2, 3, 4, 5, you know? Okay, to multiply powers with the same base, add their exponents. So if you have 4 to the 6th power times 4 to the 3rd power, this equals 4 to the 6th plus 3rd power, which is 4 to the 9th power. In general terms, if you have a to the m times a to the n, this equals a to the m plus n. All right, I lied before. Let's just go ahead and do this first example A right now. So if we have 3 to the 2 times 3 to the 6th power, this is really 3 to the 2 plus 6 power, which is 3 to the 8th power, which is 3 multiplied together 8 times. I'll let you use a calculator if you want to find that value. I wouldn't make you do 3 times 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 3. Whatever, 8 times. I won't have you do that in your head. You can use a calculator to calculate that. That's how you would do it. Okay, now let's talk about this quotient of powers property, the second one. Let A be a non-zero real number, a real number that's not 0, and let M and N be integers. To divide powers with the same base, subtract their exponents. We talked about this in the last video, finding why A to the 0 equals 1. So if we have 4 to the 6th power divided by 4 to the 3rd power, this is really like saying 4 to the 6th minus 3rd power. And remember, this is because we have 6 4s up top, 3 4s on the bottom. 3 of those are going to cancel out, and we're left with 4 cubed. Cubed is another way to say to the 3rd power. Both are fine ways to say it. In algebra, if you have a to the m over a to the n, this is a to the m minus n. All right. For this example, our base is -4, and we have an exponent of 2 in the numerator and an exponent of 7 in the denominator. You can only do this rule if your bases are the same, remember. So these both have to have a base of the same number, so they're both -4, which is good. So this is -4 to the 2 minus 7th power, which is -4. To the 2 minus 7 is -5 to the -5th power, which is equal to, I can put this base and exponent now in the denominator because this is a negative exponent. We end up with 1 over -4 to the 5th power. Finally, power of a power property. To find a power of a power, so 4 to the 6th to the 3rd power, you multiply the exponents. So if we have 4 to the 6th to the 3rd, that is 4 to the 6 times 3rd power, which equals 4 to the 18th power. So for this example, z to the 4 to the 3rd power is equal to z to the 4 times -3 power, which is equal to z to the -12 power, which is equal to 1 over z to the 12th power, because that's a negative exponent. All right, and that's these three properties. Let's scroll down and we'll do a couple more. All right, we got 3 more examples here. So, a and b are real numbers, m is an integer. Okay, to find the power of a product, so 2 things multiplied together to a power, you can find the power of each factor and multiply. So if you have a times b to the m, that is the same as a to the m times b to the m. So let's look at this letter D. This is the same thing as saying -1.5 squared times y squared. Let's see, -1.5 times -1.5 should be 2.25. 2.25, and then y squared is just y squared. That's our answer, 2.25 y squared. Okay, now, property of a quotient. Some of you saw this on the Big Ideas homework last week. So, to find the power of a quotient, so something divided by something, find the power of the numerator and the power of the denominator and then divide. So this 3 halves to the 5th power is the same as 3 to the 5th power over 2 to the 5th power. So for part E, our example E, this is equal to, we can do this as a cubed over negative 10 cubed. If you want to simplify this more, this is really a cubed over, let's see, 10 cubed is 10 times 10 times 10, excuse me, negative 10 times negative 10 times negative 10, which would be negative 100 plus another 0, which is 1,000. All right, and then this F example, 2x over 3 to the negative 5th power. This is like saying 2x to the negative 5th power over 3 to the negative 5th power. Now, these are both to the negative 5th power, so what I'm going to do is put this 3 in the numerator and put this numerator in the denominator to get rid of these negative exponents. This is going to become 3 to the 5th power over 2x to the 5th power. We can simplify this one more time, folks. We can say, I'm just going to write it over here now, 3 to the 5th power over 2x to the 5th power. This is the same thing as 2 to the 5th power times x to the 5th power. And you could simplify this further. 3 to the 5th power is 243. And 2 to the 5th power, let's see, 2, 4, 8, 16, 32 over 32 x to the 5th power. And that's your solution for that one, a simplified version. But I also would have accepted this. Okay. Properties of exponents, this is what we're going to practice all week. Got a couple other examples for you on the next page. And that's it for this learning objective 2. Be sure to memorize these properties. They'll come in handy as you go forward in your math education here, okay? And we'll do lots of practice, so hopefully they will become memorized just as we practice these, okay? So that's it for this video. Email me if you have any questions at all.